Hello and welcome to the Road to Autonomy. The Road to Autonomy is brought to you in part by Stantec Generation AV. Stantec Generation AV combines some of the most experienced AV experts in the industry with the resources of a global engineering firm. Stantec Generation AV provides education, consulting, assessment, and guidance to any industry interested in autonomous vehicles. Learn more at stantec.com. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome Trevor Crain, Mobility Research and Education Program Manager, Argonne National Laboratory. Trevor, welcome to the podcast.
Hey, thanks for having me. Really excited to be here, Grayson.
I'm excited to have you here because electrification is the future. Trains are getting electrified, cars are getting electrified, and eventually perhaps planes are going to get electrified. And we're seeing a lot of movement, especially on the vehicle side around electrification. Trevor, what are your thoughts on the current state of the electric vehicle market?
So my background in this area is maybe a little bit different than some of the guests that you've had on here. I think our focus here within Argonne National Laboratory and across all the groups I work with is in building America's mobility workforce. So we are taking a look at this not from what technology is coming or exactly what direction everything is going in, but more equipping the workforce of tomorrow to deal with whatever mobility challenges come their way. So whether that's from consumer automotive vehicles or planes or stationary grid storage, our team here at Argonne looks at how do we build revolutionary and innovative programs that help all of our workforce program participants be able to address all these different technologies. And it's going to be a huge challenge as we transition to these decarbonized forms of mobility and energy storage and generation. But our job here is to try and develop new workforce programs that can help fill that need with a diverse series of participants, whether it's university students, vocational students, or whatever other directions and workforce needs the industry requires. We help build programs that give our students the capabilities and the resources and the pathways to industry to actually make those changes happen.
To me, this is just me personally speaking, it seems that vocational schools have fallen out of favor, but yet some of these individuals have incredible skill sets. I remember I had a friend that went to vocational school to be a carpenter, and he became a very successful carpenter, building houses, and eventually became a developer because of the skills they learned in vocational school. So that's my friend that learned from the construction world and from carpentry. Are you seeing the same thing around electrification, that some of these students, that there's a pathway for a job in vocational school today in electrification?
So one of the programs that we work on here within our department is our Battery Workforce Challenge. I'll talk probably more about our EcoCar EV Challenge during the podcast today, but we do a number of different programs that are designed to address not just the need from university students or researchers, but also on the vocational side, right? There is so much demand that is coming across the entire battery supply chain, whether that's researching anode and cathode materials, building them in manufacturing facilities, assembling them into packs, and recycling on the back end. There are tremendous opportunities here for a lot of individuals that might not have traditionally taken part in this clean energy transition. And I think we have a unique opportunity here to build new programs that will help people reskill and upskill from some of their traditional orientations and focus areas and into this clean mobility transition. Because like you mentioned, all those skills that you had described that come from learning a trade or working with your hands or working in community colleges, all those can be translated to careers in the battery industry, in electrified vehicles, even in automation. So our team's job here at Argonne National Laboratory is to take those mobility needs of the future and build new workforce programs out of them. So we can build a workforce that's not just particular individuals or not just focused around researchers or engineers, but also to everyone that's taken part in making all of these plants and battery assembly processes happen so we can actually get to this electrified future, because there is going to be a massive need across not just electrified vehicles, but in the infrastructure that you need to be able to charge them, in the training that you need to be able to work on these electrified vehicle platforms. All those directions are areas that we work on here at Argonne, and we look at what the future workforce needs are across that entire industry.
The infrastructure is key. You can have the charging stations, but then you can have home battery storage. You can have large retail size at a Target or a Walmart, they're eventually going to use battery storage. So those skills can transfer to a lot of industries. I love the line, building America's EV workforce. As you develop through Argonne, you develop that workforce, you help them develop those skills. Electrification's changing. Every day there seems there's a new chemistry breakthrough, a new technological breakthrough. And now the big issue is that the charging standard, at least in North America, is changing. Ford and GM went to the Tesla standard. And now it was announced today, Rivian is now switching to that charging standard. With a fast-moving industry, how are you, with the individuals that Argonne interacts with, keeping them ahead of the technology changes? So if they learn a skill today, it doesn't become obsolete as the technology or the industry moves in a different direction.
So I can't comment on exactly what direction each of our industry partners are going in terms of charging standards, but what I can say is all the participants in our program, the way that we structure it is to introduce them to the most advanced engineering concepts of vehicles today. So whether it's connectivity or automation or electrified vehicle controls, all of those considerations, we equip them with the right tools, understanding, and kind of that systems level way of thinking and approach to problems that lets them tackle any of the different technology directions that come their way. Whether they're in the automotive sector, our students go all over the place, even beyond there as well. They have a very strong background in automotive, but I would say that one of the biggest things that we teach our students is how to work effectively in large teams. They learn how to operate in multidisciplinary environments. They learn to create effective collaboration environments so that they can actually get the engineering work done. And they can address really big, fundamental, and hard to tackle problems. So, for example, in our EcoCar EV challenge, we're not just having our students work with an electrified powertrain and get it to work. We're having them integrate new electric motors. We're having them work with existing production control systems, build software that integrates into that vehicle environment. And then they're adding connectivity and automation on top of that. So our students are able to not only synthesize the things that you would need to develop production vehicle controls, but we're having them understand all of these different disparate systems and domains at a very deep fundamental level so they can get things working as efficiently as possible and actually deploy it to vehicles. That's one critical point, is that our students don't just model things. They don't just follow one process as they go through our development area. They really synthesize everything and actually deploy it to real test vehicles. We take them out to proving grounds with General Motors and we test it on track. So that process of coming together with a team, tackling a really big, challenging problem with a diverse team of multidisciplinary students, partnering with our industry sponsors to make it happen, and actually going out and making a vehicle work at the end of the day is incredibly challenging and sets up really well. No matter if you go into a charging job or a battery assembly or design job or a connected or automated vehicles effort, it really doesn't matter what focus area they end up in. The foundational design of our program is set up so that whatever sector and whatever job they have when they move into industry or government or academia, they're well equipped to address those challenges.
The EcoCar Challenge lasts over 4 years. How often do those teams have access to the proving grounds? Perhaps one team wrote a new algorithm for the automation, or there was a breakthrough, figured out how to triangulate 5G signals in the vehicle. And obviously you're going to want to test that on a proving ground. How often do those teams have access to that? Is it broken down by milestones? Is it by a reservation system? Or what does that look like?
I think there's a few parts to that question. So part of this speaks to how we design our program in terms of the multi-year approach. We model this multi-year approach based off of the approach that OEMs are using in their design processes as well, in addition to what the students are doing. So I know a lot of competitions and research efforts are 1 year or 2 year. The reason why ours takes a multi-year approach is, for one thing, they're doing really complicated things. They're taking a stock vehicle, taking it apart, putting in a whole suite of new systems, a bunch of new sensor modalities, getting it all to work as a system. So to your question of how often do they test at proving ground facilities, I think maybe a slightly different question is how often do they test their systems in general and how? So our students throughout the years of the competition start in more of a virtual design phase. So the first year is mostly simulation and design. They do some hardware work with deploying some code to target Rapid Control's prototyping hardware, but it's primarily focused on let's make the best possible product to meet the needs of the competition and the wider industry as well. Our next years of the competition, years 2 through 4, are focused around deploying that technology into the production vehicle platform. As they do that, they do a number of different testing and development exercises on both bench and in vehicle as well. So one thing we try to do is equip each of our university teams with the hardware, software, and facilities they need to actually test their system throughout that development cycle. So they are universities, which means they don't have access to proving grounds constantly. And moving vehicles to a proving ground is an expensive endeavor. It's not like if you're an OEM and you can design some code, flash it to a new vehicle, and take it out to the proving ground whenever you can get the schedule lined up. It's for a university team, it's a significantly larger challenge to get track time or dynamometer time or any other sorts of resources. It takes a lot of effort on the competition side to organize those events. So we try to have a competition event at the end of every single year. So the first year is more design and presentations. Year 2 is more checking their integration and the functionality of the vehicle after they've integrated all the new propulsion systems, some of the new sensor sets, and everything else. Year 3 and 4 are more focused on actually running these test vehicles through the different processes and methodologies that we developed to be able to test them, because our university teams are developing very unique capabilities. They're sometimes in advance of where the industry's at. For example, we have our students developing connected and automated vehicle algorithms where the vehicles will be able to communicate with I-to-V connected traffic lights. They'll be able to know signal phase and timing information so that they can approach and depart from intersections in the most efficient manner. And they're actually implementing those algorithms and trying them out on their vehicles. So we try to do at least 1, generally 2 testing events per year. And we supplement that with a fair bit of testing at the university facilities themselves. So many of them have access to test tracks near their home university areas. Some of them have dynamometers. It's a little bit of mix. But regardless of the specific university capabilities, we want to make sure that all of them have the tools and resources they need to actually test these vehicles out.
It's really smart. How many teams are part of the challenge, and what does a team have to do to apply to be a part of the challenge?
So we have 13 teams present in the EcoCar EV Challenge. That's across 15 different universities. So one of the new areas that we've got in the new EcoCar EV Challenge is we've allowed partnerships between multiple universities. So for example, our year 1 winners in the last month or so, the Ohio State, they partner with another university. So the Ohio State partners with Wilberforce to be able to actually, which is an HBCU nearby, they actually co-develop a lot of the systems on board our test vehicle, which is a really interesting collaboration that lets us add a lot more participants from a lot of different backgrounds to be able to come together and make this vehicle work. So in order to actually get into the competition, we go through a pretty rigorous request for proposals process. Argonne manages and oversees the overall process and the competition itself. We put together this request for proposals that's then transmitted to universities across North America. So both the US, Canada, and Mexico, universities across all those domains are open to apply. And then we go through a fairly rigorous selection process where we work with our headline sponsors to narrow down which universities have put forward the strongest applications and have the greatest potential for success in our program. Because one of the things about EcoCar and other similar programs that we put together is that they're fairly resource intensive. We need to be able to get vehicles to universities. We have multiple pieces of hardware and software that we need to train the universities on to develop that talent and that technical background and actually work hand in hand with them to get this to happen. So we have a limited number of universities, but we have a really, really large impact overall. So our competitions have been running for about 35 years now. And through that process, we've graduated tens of thousands of students into the automotive industry. And they've evolved a lot over the years. We started back a long time ago with a completely different focus for our historical competitions. The goal of it, though, is to evolve how we do these competitions every single series. So the last competition, the EcoCar Mobility Challenge, was more focused on adding hybrid technology to a Chevrolet Blazer. We also added some levels of automation and connectivity to the vehicle, but it was more focused on the powertrain development coupled up with adding some of that connectivity and automation as well. The new competition is an EV platform. So our students, rather than integrating hybrid drive systems, they're now in the EV space, which takes similar but not completely the same set of competencies to be able to integrate electric vehicle motors specifically to get them working with a fully electrified vehicle platform, and most importantly, to add a lot of connectivity and automation features that really pushes past even where a lot of industry is at right now in terms of what's available. So you can't necessarily go out right now and buy a vehicle that can communicate with connected traffic lights, can communicate with connected vehicles, because there's not a ton of vehicles that have that capability right now. So there's not as much reason to develop for the OEMs and the private industry side. There's less of a driver to put out vehicles that have that capability. There's a few on the roadways, there's a few examples, but what we're doing within our competitions is actually pushing beyond there, challenging our students to be able to develop vehicles that can connect to traffic lights, connect to other connected vehicles, and drive the vehicle in an automated fashion in the most efficient way possible. And we're taking things out of the research realm and into the actual application realm on board our real test vehicles.
It reminds me of a very great line of an incredible individual with a great imagination, Walt Disney. And Walt Disney, with his original animators and the team, he always had the term plus it. This is great, plus it. And so you're basically saying to your students, in the words of Mr. Walt Disney, plus it, because what Disney did, he unlocked imagination. You're allowing your students to unlock imagination and build things. With the big shift towards electrification is coming, and I want to add some context to it because Bernstein research is predicting that battery electric vehicles will reach 40% penetration globally by 2030. That's a large number, 40% globally by 2030. One, we're going to need a heck of a workforce for that, and that's where you're stepping in. And on the other side is the infrastructure that's going to need a workforce as well. How do we ramp the workforce up? 2030 is only 7 years away. It's not very far because we're going to have some individuals might want to work on the battery in the vehicle and some individuals might want to work on the charging infrastructure. How do we accelerate the workforce to meet this prediction that Bernstein's making?
To be perfectly honest, where we're at right now, we don't have the workforce to be able to meet that need. We're going to have to scale up across multiple different sectors, across multiple different job areas, from the engineering research side to application within industry to a lot of what I mentioned earlier, the vocational workforce as well. And really, we're going to need a rapid expansion across all those different areas. And that's a big part of what we focus on in programs like the EV Challenge. And I think one of the key drivers there is by building these connections and these collaborations that's not just in the research realm. What we do with an EcoCar EV Challenge, we work with our headline sponsors, General Motors, the Department of Energy, and the MathWorks, along with a host of other sponsors to make sure that all of our student participants have the resources and the experience and the connections that they need to hit the ground running and really ramp us into this electrified mobility transition. And I think it's not specific just to vehicles either. We're building workforce programs in our battery workforce, the entire supply chain. We're collaborating with industry and government partners to be able to make that happen. We're looking at the infrastructure side as well, in terms of how do we develop the talent and capabilities to be able to install a lot of these charging stations, whether it's DC fast charging on highways and other areas, or whether it's looking at level 1 and 2 installations in different neighborhoods than you would think to install them in. So right now, there's a massive challenge that we're facing in this road towards decarbonization. And I think it is really, really critical that we build a workforce that's educated and experienced very quickly so that they can jump into the industry, into our private sponsors, and be able to tackle some of these challenges. And I think one other thing that's worth mentioning is I think we have a really unique opportunity here to build that workforce in an equitable way. So making sure that we work with diverse university and vocational partners, making sure that our students are equipped to handle a lot of these different considerations across a multitude of different sectors. To be frank, it's going to be a huge challenge, but that's what our team is trying to do is we take these really big, hard to address challenges. Let's say, just take connected and automated vehicles, for example. Okay, we need to equip a workforce that is able to address the needs of this wide, huge industry that spans commercial applications, OEMs making private vehicles, even things like ports and everything else that you've got to deal with. How do we build workforce programs that give our students kind of that fundamental baseline of understanding so that they can go out and seed the industry with the talent that it desperately needs? That's a big part of what we figure out how to do is take that big unapproachable problem and make something that's actually actionable, something that's executable, something where at the end of the day, we've got 13 university vehicles that we can take to a test track, run them through a connected corridor demonstration where they're following physical test vehicles, where they're communicating with connected traffic lights, where they're using prototype electric vehicle drive systems, doing all of that in the context of this really, really challenging mobility transition tries to set them up in a way that's pretty unique, I think, across a lot of different other programs. So yeah, in short, it's going to be a huge challenge. We're going to need to pull people from a lot of industries and areas that we hadn't thought of before as a country. And we're going to need to really accelerate our training and workforce programs and build in those pathways to our private and public industry partners to where we can make this change happen in an equitable and rapid way. It's going to be a huge challenge, but we're really looking forward to it.
It's going to be a challenge. It's going to be a gigantic challenge, to be very frank with you, but you don't have to graduate from university with an electrical engineering degree to participate in this. One idea that I keep thinking a lot about is you get an individual who's very good at electric, they're an electrician, they make a little niche and they start, I will install electric chargers at your home. I'll start at multiple family dwellings. And he acquires one company, acquires two companies, and all suddenly you've got a very big profitable business that's supporting his family and doing good in the community with creating jobs. So you have that as one aspect that somebody's going to figure out to roll that up. And then you mentioned the battery tech, and that's getting interesting. Bernstein Research is forecasting that battery capacity will rise from 600 gigahertz in 2022 to 2,700 gigahertz by the end of the decade. Again, 7 years away. We're going to need talent for that as well. Outside of the program that Argonne's building, so you have the individual that's an electrician that says, okay, I'm going to roll a bunch of these businesses up and I'm going to do really well. And then you got the individual that says, okay, I'm going to go to university. I'm going to learn battery tech. I'm going to learn electrical engineering. Outside of the program that Argonne's doing, how do we spark that imagination in these individuals? Say, hey, there's a really big career path here. And oh, by the way, there's a very big opportunity in the TAM, the total addressable market. It's only growing. It's not shrinking.
I think maybe one short answer to that is unconventionally. We have to look at this problem differently than we've approached it in the past. I mean, you're taking an industry that normally focuses on certain areas and certain aptitudes and certain educational backgrounds. We need to take a step back and look at the broader picture of how do we get educational programming deployed at a national scale? So not just at 1 or 2 or 10 universities, but at community colleges across the country. We need to look at deploying workforce programs into communities all over the place. We need to really reshape how we think about building workforce programs and how we do talent acquisition and training across all these different industries, because there's very, very quickly going to be a bottleneck of potential workforce that if we don't change how we train these students, if we don't scale up how we develop these workforce programs to meet the needs of this transition, we're not going to meet those targets. And I think that's a big part of what we at Argonne National Laboratory are working towards is rethinking not just our existing workforce programs like EcoCar. We're also looking at building new workforce programs in the battery workforce space. We're looking at collaborations with vocational colleges, with trade schools, with unions. There's so many different directions that we need to go in to be able to address the mobility needs of this transition, that the real answer is that we need to rethink how we do everything. And I think we've started down that pathway quite a bit, both internally here at Argonne and with our industry and government partners, but it's going to be a big lift. And I'm excited to see where it goes, but it is going to be a huge challenge.
Do the days of the apprenticeships come back?
I think so. I think that's probably an aspect of it. I will say that my particular area of expertise is more in the connected and automated vehicles realm. So I can't speak in detail to all the things that we need from the vocational, the regional workforce, the reskilling and upskilling side. But I think we need to relook at how we build these programs, whether we rely or to what extent we rely on things like apprenticeship programs, how we deploy regional training in areas where we need it most. Let's say you've got a manufacturer that wants to make a battery plant. How do we get them the tools and the workforce that they need to actually make that happen? And how do we make sure, as every manufacturer is starting to do this, how do we find the workers and build those opportunities regionally and nationally to be able to address those challenges? And I would say it's an open question. I think we have a lot of great solutions and a lot of good program ideas and structures, but now we need to deploy them and scale these projects up and make this fundamental workforce change happen.
We have to make the change happen. I would hope. I'm a fan of the apprentice programs for a variety of reasons. If you look at post-war Japan and what Sony did, a lot of the early employees started an apprentice program to learn how to build electronics, which brings me to Toyota, because they're going to introduce their liquid lithium-ion batteries, the next generation EVs platform in 2026. And if you think about that, and let's say Toyota's a very big presence in Plano, Texas, here in the United States, that even if it's, say, 100 students, employees that become this, they go to an apprenticeship program. I like it because then the student's not incurring debt. They're making income and they're acquiring a skill and they're not incurring debt. That's the holy grail. How can we have individuals incur the skills without incurring the debt? If we can figure that out, we can build one heck of a workforce.
And there are diversity considerations too, as you look at building these programs with students that aren't coming from university, where they are, like what you said, incurring debt, spending multiple years in this project. I think there's absolutely a place for that and will always be, but we need to supplement it with additional programs like apprenticeship areas, like trade schools, like all of these different approaches towards building this workforce in a way that's not just about the traditional higher ed focus of put in a lot of tuition funding, spend several years, graduate, go on. I think we need to look at new models and new pathways to make all of this workforce effort more inclusive to people that might not have the means to be able to just take a year or two out of their lives and reshape everything they know and then go to a new career pathway. Like, that is a lot of risk built into a big change and a lot of need that you have in terms of financial, in terms of everything from childcare to everything else, to actually make a change like going to university happen. So I think in lieu of that, we need to look at new mechanisms. We need to build in new pathways with our industry partners to where we've got something like an apprenticeship program where they are paid to do this. It's not like they're doing this out of their own pocket or putting a pause on their current career to try and switch gears into the electrified mobility space. We need to make it easy. We need to make it accessible, and we need to make the connections to actually impart this change across the whole industry, across the whole country. It's an enormous challenge. Absolutely.
I'll use an automotive pun. We need a hybrid approach. It's not a one-size-fits-all solution. One of your partners in the EcoCar Challenge, very kindly, GM. I think what Ms. Barry Barr is doing at GM is nothing short of fantastic, as she's getting them preparing for electric future, and the way that in her commitment to Cruise is nothing short but fantastic. So Ms. Barr, thank you for your commitment to the future. As part of the program, GM donated a 2023 Cadillac Lyriq. That's a really big commitment, and I think it's really cool. So let's put on our engineering hats for a moment here. Will the students have access to the CAN bus?
Our students are working very deeply with all the technology on board the vehicle. So they are integrating the software they develop into the production systems. They're working with both production and prototype hardware, and they're putting it on board the test vehicle. So there's a lot of integration and software development that has to happen in collaboration with GM. And I'll say that General Motors has been a great supporter of these programs over the years. There's no way that we could do it without their level of commitment, support, and backing. And that goes for all of our headline sponsors, from the Department of Energy to the MathWorks to also all of our other sponsors as well. To make a vehicle system like this work, where you've got motors, you've got LiDAR and radar and camera sensors. You've got battery technology. You've got rapid prototyping controls. All of these elements require significant participation from our industry partners. And it's really that participation that makes these competitions happen. And I think it's also that participation gives us those pathways into industry, because our students don't just work using tools that are traditionally used for research. They're using automotive grade hardware. They're using the same development environments that auto engineers are at OEMs or at tier 1 suppliers, tier 2 suppliers. They're going out into all these industry partners and they're hitting the ground running because they've already had the experience of working in a big team, using the actual hardware that's in use at these companies and using it to make something real happen. It's like deadlines drive progress, right? And what better deadline do you have than getting an entire vehicle to work at a General Motors proving ground?
Got a lot of pressure.
Absolutely. And that is honestly a big part of the training too. It's learning how to not only perform the engineering work to make it happen, we also challenge our students to present on their work to very high up individuals across our industry sponsors. I remember, so I was a student, my background is I originally started an EcoCar 2 team back in, I believe that was 2014 at the University of Washington. So I was initially a student in competitions. I spent 3 years as a team leader and controls team leader. And I can tell you some of the most fundamental things that I learned out of that process. The engineering side was one thing, but the most important side was learning how to work as a team, how to take a really large fundamental problem, like let's make, in our case, a plug-in hybrid biodiesel Chevrolet Malibu. How do we select all the components? How do we put it together? How do we actually make it work? How do we source everything? We were doing all that, and we were installing a vehicle laboratory at the same time. So not only were we building a team from scratch, we were helping install vehicle lifts, planning out experimental setups. We were getting the right people on hand to help really push this laboratory into the next phase. And I think the biggest thing that I took away from that, the technology is great, and I think it's really interesting and important. But I'll say that the ability to work with other engineers, work with communications and business students to build a cohesive product and then present on that, like you said, in high pressure, high profile environments to very high up people at all of these different sponsors. I was giving presentations as a first year master's students to CEOs of companies that were then hiring students directly out of our program. And I think that's the critical linkage that our students are able to come away with from our programs. They aren't just engineers that will go and work on a certain widget or a certain small component of their area. They understand things at a system level. They can speak eloquently and detailed fashion about everything they work on and present on it to higher ups at all these different companies to demonstrate that they know what they're doing, they are following rigorous processes, and that they're well equipped to enter the automotive industry, or for that matter, whatever sector they go into.
The nail on the head is they're learning public speaking skills. That goes a very long way no matter what career you go into. If you're presenting to a CEO of a major automotive company, a Fortune 500, or a tier 1 supplier, you have to be able to communicate properly. And if you can, you have the keys to success. When you were doing your program and the students today, did you get to modify the sensor suites, add your own sensors, reconfigure it? Perhaps you wanted to run a different piece of software on top of the radar, anything that technical?
So our students are integrating new sensors into the test vehicles. They're using some existing sensors, but they're adding new modes and new sensors, everything from LiDAR to radar to cameras. They work with a number of different modes, and they work to fuse all that data together. So they're not just making a self-driving vehicle algorithm with a sensor fusion input. They're making the entire sensor fusion system, fusing that data together, developing the algorithms, and they don't want to do it in just one situation or just one application. They're taking and being able to develop these systems with an energy-centric perspective. And I think that's really critical to our competitions is that they're not just doing something to make it happen. They're doing something with an eye towards energy, with an eye towards safety, with a rigorous design process, and really tackling this problem with a holistic understanding of the whole vehicle as a system, of all these different sensors, and in the process, doing really low level, detailed, and challenging technical work.
When a team's making the GM Cadillac Lyriq autonomous, at the same time, are they looking to optimize the range of the vehicle? Perhaps they're going to use a lower power ARM chip versus an NVIDIA GPU just because of the pure power consumption, or perhaps we're going to dial back the air conditioning, or just different things that historically take away at range where the team's looking to optimize that?
That's in fact one of the largest focuses of our competition is not just adding levels of driver assistance or connectivity to the vehicle. They're actually doing all of this in a way that gets the lowest energy consumption. So one of the things that I do actually in my work here at Argonne is not just supporting student competitions. It's not just supporting workforce. It's actually researching ways that we can test these connectivity and automation features on board real test vehicles to understand what their energy impacts are. And that's one area that our EcoCar EV Challenge actually helps us push the testing industry forward as well, because at the end of the day, we have to test our vehicles on test tracks and dynamometers using very advanced algorithms that aren't even in production vehicles yet. So yeah, our students, the vehicles are tested on specific evaluations on circle tracks at proving grounds, on dynamometers, to see how efficiently the systems operate, how efficiently the features can drive the vehicle, and compare it across all the different vehicles in our competition. So we're not just looking at it from here's how much energy this one vehicle used. We're also considering here's how much energy this particular prototype used compared to all the different university vehicles, and also compared to what the state of the art is for adaptive cruise control and driver assistance systems that are on the market today, because every context matters here. We want to help our students make features that can actually save energy in the context of the current state of the art. We want them to think about customers, so not just make features that are only oriented towards energy and a customer would never buy down the line. We need them to think about this from a customer-centric perspective, but one that really emphasizes the energy impacts and the environmental impacts of the vehicles that they work on.
Let's say a student team had a major, and I emphasize in bold that technological breakthrough. Is there a path for those students to patent that major breakthrough?
Our university teams, it depends on the exact agreements that are in place between each university and our partners, but generally our students and the universities involved do have the rights to retain a lot of the IP that they develop as part of the competition. And I will say that on the whole, students that graduate from our competition when they go into industry, they also tend to produce patents and other outcomes as part of their job functions at a significantly higher rate than their counterparts that didn't take part in a workforce program like this.
They have the skills. At the end of the day, for Argonne and for your partners, what does success look like when the program wraps up?
That depends on who you talk to. If you're looking at this from a university's perspective, we have a winner that comes out of these competitions. We have a first, second, third, fourth place. But I think really the biggest outcome and the biggest success metrics that we make are the degree to which our students are going into the industry. It's what salaries are they making as they enter their industry careers or their careers in government, whatever direction they decide to go in. Are they having improved salaries? Do they have better access to jobs? Do they come away from this EcoCar or other workforce experience with this foundational understanding and connections to make their career be launched into the stratosphere? And that I will personally, that is something that as a student, when I was in competitions, I could not have predicted the career trajectory that I would have if you talked to me back in my senior year of college. If you would have told me that I would go to Argonne, manage workforce programs that range from hybrid and plug-in hybrid vehicles to adding advanced driver assistance systems, to adding connected and automated vehicle algorithms, and researching the future for how we test these vehicles, there's no way that I could have predicted that I would do that. And I think if you talk to any of our EcoCar or workforce program participants, you'll find a similar answer. It's this set me on a career trajectory I never would have expected. I have so much more success and background and knowledge coming out of this program that I never would have predicted based on just my classwork. And I think that's one thing is when our students go into an interview, when you get asked questions like, can you give me an example of when you had conflict on your team or when you collaborated to solve a problem? Yeah, our students, when they're in the interview process, they have a really unique ability to talk about what they've done. They can say, yeah, I've gone through and I've designed and implemented a battery pack in our past competitions. They can say, I've worked together with a team of engineers to develop algorithms and deploy them on real test vehicles for navigating connected corridors in the most efficient way. They can really talk to those lived experiences, and they can show that they haven't just taken part in classwork. Classwork is important. You get a lot of really great learnings out of it. But I think these student projects like EcoCar, like our battery workforce efforts, they're so critical in building these unique experiences that our students can then take, utilize the connections, utilize the experiences, and go on to make real changes in the automotive industry. That's what success looks like to me. It's success to me is going to General Motors, looking at anyone working on hybrid vehicles or powertrains or calibration, and you can't look left or right without seeing a student that came out of our competitions. That's what success is. It's driving the industry forward, equipping our students to do really, really fundamental, big and challenging things, and helping them hit the ground running once they finish our competitions in whatever industry they decide to go into.
The challenges are laying the foundation for success because they're learning the skills, a variety of skills, interpersonal skills, engineering skills, technical skills. They're learning all the skills they need to succeed as they move towards a future that's full of electrification. In your opinion, Trevor, what is the future of electric vehicles?
The future of electric vehicles, that's a challenging question. I mean, it depends on who you are, what industry you're in, and what your priorities are. What I can say is that no matter what direction that future takes, our students will be able to handle it, whether it's hybrid vehicles, electrified vehicles, whatever levels of automation get introduced into all of our vehicle platforms. We're equipping our students with the skills and capabilities they need to be able to handle the changes in the mobility industry as a whole. And we're setting them up well to be able to hit the ground running, enter these industry jobs, and really make fundamental changes and help them define what the future of electric mobility looks like. I think maybe that's the real answer here is I don't know myself completely what the future holds, because I think a lot of it's going to be driven by our workforce program participants and by the new workforce that's entering all of these different jobs.
What we do know we can all agree on, it's going to be interesting. There's going to be a lot of change. There's going to be a lot of skills needed for a lot of new jobs that are going to be created. As we look to wrap up this insightful conversation, Trevor, what would you like our listeners to take away with them today?
I think maybe one of the biggest things is that we're entering a period of huge transitions, and it's really, really critical that we approach this time of transition with an open mind, with innovative new programs, and with an approach that equips our future workforce with the abilities they need to address whatever direction the automotive industry goes in, whatever direction mobility as a whole goes in. I think it's really important that we build programs like our EcoCar EV Challenge that equip our students with the ability to address all those challenges. So if there's anything to take away, it's there's tremendous opportunities in the mobility industry coming up. There's a lot of opportunities in Argonne programs and outside of there as well. So keep an open mind no matter what your current career is, because things are going to be changing really quickly, but there's going to be a ton of different opportunities that come out of that change.
The change is going to be exciting. The EcoCar EV Challenge is helping to develop the workforce of the future, a workforce that we very much need here in America. The future is bright, the future is autonomous, the future is developing America's EV workforce. Trevor, thank you so much for coming on the road to autonomy today.
Absolutely. Thank you for having me.
If you've enjoyed listening, please kindly rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter, Instagram, and YouTube at Road to Autonomy, or email podcast@roadtoautonomy.com. The Road to Autonomy podcast is produced by the Road to Autonomy LLC. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect those views of the Road to Autonomy, its subsidiaries, its shareholders, directors, investors, or partners. The content discussed on this podcast is for informational purposes only. It should not be taken as legal, investment, tax, or business advice. Nothing is a recommendation that you purchase, sell, or hold any security or other investment, or that you pursue any investment style or strategy. The content of this podcast is presented on an as-is basis with no warranties, express or implied, of any kind. Financial mentions about companies in the Road to Autonomy Index and discussions about the Road to Autonomy Indexes are for informational purposes only and should not be relied upon when making any investment decision. Furthermore, an inclusion of security within the Road to Autonomy Index is not a recommendation by the Road to Autonomy Indices LLC to buy, sell, or hold that such security, nor is it considered to be investment advice.